now that we know how to find our amplitude and our period, we are going to graph these. Some other key important parts that we're going to do is we're going to find the intercepts to help us graph these as well. So for sine, we know that we start at a height of 0. So this first location shouldn't be surprising to us. And then wherever our period ends, or wherever our degree measure ends, so 360 divided by b, which represents our period, that is where we finish. If I want to find another intercept, I need to take half of whatever my period is. Right? So in this video, I'm just going to focus on sine. We'll do 2 of them. So I want to find our amplitude, our period, and I'm going to say our intercepts as well. Our amplitude, we know, is our A value, which is a height of 2. Our period, we know, is 360 divided by whatever B is. In this case, B is 1. So it's 360 divided by 1, or 360. And then our other intercept that we really need, we already know about 0, 0. We already know about 360, 0. But we want the middle one. We need half of 360, which is 180 degrees. Right? So now we can graph this sine function. I'm going to ask for 2 cycles. I'm going to start with our period, or our amplitude. We know that's a height of 2 and -2. Next, I'm going to put in 1 cycle, which is 360. And if I want 2 cycles, that's going to come up to 720, because I have 360 plus 360. I'm just adding on another period. And then I also want to put in our intercepts. So I'm going to label our intercepts in a different color. Remember, our intercept is half of this, so 180. And the other one is going to be right in the middle of this. You can take 180 and add on another period, which would get us 540. I believe. I'm going to double check that, but I believe that's correct. That is correct. So we know now that we can graph a few points in here. Since we're dealing with sine, remember on our original function that we graphed, our height at 0 degrees was 0. At 360, we better be at 0. And at 720, we better be at 0. We're also going to be at 0 with our intercept, which was 180 and 540. Sometimes I like to put in these dashed lines up here at the top. That way I can easily graph this just a little bit better. Know that I got to get to that height. As a quick reminder, remember we started at 0. We got to get all the way up to a height of 2 and then back down to 180. I got to get through 1 full cycle. There's 1 cycle. There's 2 cycles. There would be a graph of sine of, or 2 sine of theta. Let's do one more. Let's do 2b as well. And just focusing on sine for now. So in 2b, I want to come up with what is the amplitude, the period, and I want to know at least 1 intercept. Our amplitude this time, we're only going up to a half. For our period, we take 360 and we divide it by our b value, which is 2, which in this case is 180. For our intercepts, we take 180 and we divide it by 2 or multiply it by a half. So we would have 90 degrees. Graphing this time, our height is a half and negative a half. Our period this time is not 360, but it is 180 degrees. Another cycle would then be 180 plus 180, which is 360. Then we also need to put in our intercepts, which is at 90. And then since we are adding on a full period of 180, we're going to add 90 and 180, which is going to get us 270. Again, sine starts at a height of 0. We're at 0 once we reach one cycle, which is 180, and our second cycle, which is at 360. And then we're also at 0 at our intercepts, which are 90 and 270. Drawing these again, we can draw in our graph. Got to go through 90. There we go. Those would be what sine functions look like.